Hi everyone, in this video I'm going to show you how to work with shapefile data in an R environment. We are going to learn how to import it, view it, plot it, apply some filters, convert it into a data frame, and then also export it as either a CSV or a shapefile. So we're only going to be working with one shapefile in this video, but if you have a shapefile that's different, please feel free to use it. This is just an example. So the data that we're going to be using is from the City of New York Open Data Portal. It's the 2018 Central Park Squirrel Census. This is a very famous data set and it's very popular for homework projects and classroom work. So I'll provide a link and all you have to do is click the export button here, and then you can download it as a shapefile by scrolling down, clicking shapefile, and then clicking download. And if you do this, we'll be using the same data for your work as well as my work. Okay, so I have my RStudio window open here, and we can go ahead and start coding. The first thing I want to do is set my working directory to where my data is saved. So what I'm going to do is click Session, Set Working Directory, and then I'm going to choose the directory where the squirrel shapefile is saved. So let me move this video down a little bit. You'll notice that my squirrel census data is saved on my desktop, and on my desktop there's a folder where you have a folder name essentially. You have a folder called 2018 Central Park Squirrel Census. Make sure that you're clicking that as opposed to just the desktop, because then we can go ahead and import the shapefile directly without having to worry about any folder names. So you should have the same folder name as me, because we're working with the same data, and if you just make sure that it's set to that folder, we'll be on the same page. So I've set my working directory. The next thing we want to do is import the libraries that we need, and we're very lucky because we only need one library, and that's the SF library, which stands for spatial features. So I'm going to go ahead and import that library and click Run. I've already worked with this library before, so it's already installed. If you haven't, just make sure it's installed before you import it. Okay, so that's pretty much it for the setup. We're gonna go ahead and import the shapefile into our RStudio environment. So I'm going to call my file sq.census. And the function for importing a shapefile into R is st_read. Again, that's from the SF library. And in the brackets, all you need to do is type out a pair of quotation marks, and then within those quotation marks, type out the name of your shapefile. So if you're using the squirrel census like me, the name should look exactly like this. And you'll notice in the folder, you'll have quite a few files to work with. I can pull it up here. We have 5 different files, and all of these files are necessary to work with shapefile data. So if you're missing the PRJ, the .prj file, or the .dbf file, working with your shapefile would be a bit more challenging. So they're all necessary, but all we need to do is import the .shp for shapefile. So let's run this line of code. Run, and it was successful. It should be pretty quick because it's not a big file. So you'll see when you import it, it pulls open a series of notes telling you what you've just imported. So we have an Esri shapefile. It has 3,023 features. So there were more than 3,000 squirrel spottings in Central Park. And each entry for each squirrel spotting has 30 descriptors. So again, if you don't know much about this data set, it's basically a data set where people have inputted information on squirrels that they've seen across Central Park, and you get we can look into it, but you get information on what the squirrel looked like, what time it was seen, its gender potentially, and some other information. So it's just a really fun data set to work with. Let's take a look at what it actually looks like. So we're going to type in view in the editor, and then type in sq.census, because that's the name of our variable. And you can see here, it'll pull open a separate window. This is if you're using RStudio, obviously. And we have an X and Y coordinate. We have a unique ID for the squirrel, and that's the unique ID right there. We have the shift, so whether you saw it at AM or in the daytime, AM, or the evening, and a lot of other information, like you have the primary fur color, things like that. And yeah, you just get a lot of information for working with this data set. So that's what you get, or what you see when you import a shapefile. You also get a bounding box for the max and min extent of the data. You get a projection, and you get a geometry type. So we're looking at single point data. If you are working with a polygon or a line data set, it'll say either polygon or line. So that's pretty much it. This is what you see when you import a shapefile. And we can also just run it in the console as well. And you can see that you get a sample of the data set when you just type out the name of the variable. You get the first 10 entries. So there's quite a lot of data that comes with a shapefile, this particular shapefile. And you'll notice that the last column is a geometry column. So this is a breakdown of each feature in the, this is the breakdown of each feature in the data set, as well as the coordinates. So because we're working with single point data, we get a Latin long per feature. But if you were working with a polygon or a line data set, this will look a bit different. Okay, so we've actually already reviewed the data set, so we know what it looks like. Let's go ahead and plot the data set as well, because that's the most exciting part of working with spatial data, in my opinion, plotting it. So let's go ahead and do that. So I'm going to keep it simple for the first go of things. We're going to do plot, type out plot, because that's the function to visualize your data. And then the name of the variable, squirrel census, and then click run. And you'll see you get quite a few images pop up. And if this shape looks strange, basically what's happening here is that shape is the outline of Central Park, or the boundaries of Central Park, because all the squirrel spottings are in Central Park. So if we zoom in a little bit, you'll see that that Central Park shape actually is made up of thousands of small dots, each dot being a squirrel sighting. So each one of these images represents one column of data in your shapefile. So if we go back to our view window, we know that we get an X column and a Y column. So right off the bat, the first two images are a breakdown of the X values and the Y values. These are not particularly useful. I don't really need my latitude and longitude values plotted like this, but essentially what's happening here is the X value for each dot is being color-coded and plotted in this format. You can also see some of the more interesting variables, in my opinion, are age and primary fur color. So here we have an age of the squirrel, and this is color-coded based on age. And again, primary fur color, each dot represents a different color for the squirrel. And it looks like whatever gray represents, that's the most predominant fur color. So we'll dig into that a little bit more. If we go over to unique.squ, so unique squirrel ID, you'll see that there's many, many different colors, and they all represent a unique squirrel ID. So you should have 30 of these plots, and when you plot it in R, you get a sample of around 9 of them. And like I said, a lot of these are not particularly useful, so the X and Y ones aren't useful for me, but I think age and primary fur color are interesting, as well as shift. So when did you see the squirrel? So if you just want one of the plots, you don't want to see all 30, we can plot just a single variable as opposed to all 30. And the way you do that is by specifying the column that you want to plot in the plot function. So I only want to see age. So I'm going to add square brackets next to my variable with quotations, and then in the quotations, you type out the name of the variable. And then you get a plot of the age. And it's a lot easier to look at. You can see here that there's 3 different ages. There's juvenile, adult, and then green, which is undetermined, I'm guessing. So it seems like most of the squirrels that were plotted in Central Park were adult squirrels. The next thing we're going to do is filter our data set. We have a lot of data that we're currently working with. We have more than 3,000 squirrel sightings and then 30 different descriptors for each squirrel sighting. So that's quite a lot of information, and often you don't need to really use all the data that you're given. So we're going to filter down to a few parameters that we're interested in and then plot it again. So before we do any of that, I'm also going to import the tidyverse library. This is a really popular library for working with data sets, and if you've never worked with tidyverse before, I highly recommend watching my video on how to use tidyverse before doing the next section, because I'm going to be using a lot of the functions from the tidyverse package. So the first thing I want to do is create a new variable. So sq.census.to, and I'm going to reference the original shapefile, squirrel census. And the first thing I'm going to do after referencing the squirrel census variable, is apply a filter. And I think what I'm going to do is filter for age. So we have a couple options here for age, and I'm going to only include adult squirrels. So age has to be equal to adult. And the reason I know that it's a character variable is because if you pull open the squirrel census data frame again, we have the age column, and it's not numbers like 1, 2, 3, it's adult and juvenile, and that's obviously verified in our plot here. So we're going to do filter age equals adult. We can run that for now and then view it. Census.to, and you can see if we scroll over to age, we only have adult squirrels. I think another interesting one to filter for would be primary fur color, and I think cinnamon is a fun fur color. So let's add a filter for primary fur color. So the variable is primary.fu, and the value is cinnamon. Let me make sure I'm spelling that correctly. Cinnamon. So let's run that again. And if we go back to squirrel census 2, the data frame, you'll see that we now have only cinnamon as our primary fur color. And our original data frame, squirrel census, had 3,023 entries. Our new one only has 326. So we've cut out 90% of the data just using 2 filters. Okay, so so we run that. We can plot it again, actually. Create a new plot. So plot squirrel.census.to. And you can see now, if we zoom in, we have less data that we're working with. And you'll notice that age and primary fur color, they have only one color because we've only included adult squirrels and we've only included cinnamon colored squirrels. So there should be no variability in the color of the dots. Okay, so if you have worked with shapefile data and you want to actually convert it into a CSV, you may want to drop the geometry column. And what I mean by the geometry column is the column that's almost always at the end. It looks like this, and it allows R to plot the data that you're working with. Often when I'm working with spatial data, I want to remove this column so that I can use it in a machine learning model or something like that. So if you want to do that, all you need to do is use a function called st_drop_geometry. So we add another tidyverse pipe, and then we do st_drop_geometry. And if we run that, you'll notice that at the end of the column, the geometry column is gone. So now it's no longer a shapefile. It's like any other data frame that you would get from a CSV. And if you want to export that, you can go ahead and type in write CSV. So let's do that, write.csv, and then we can do the name of our variable, squirrel census 2, squirrel census 2, and then we can give our CSV a name, so sample.csv, run that line of code, and this will export your filter data frame as a CSV. So this is what you can do if you want to essentially remove the spatial components from your shapefile. If you want to export it as a shapefile, what we can do is use another function from the spatial features library. And that function is called st_write. So let's go ahead and do that. st_write. In that function, you need to provide two main arguments, the shapefile and the name of the shapefile. So I am going to get rid of the st drop geometry so that I can convert this data frame back into a shapefile. Okay, I've removed the function. I'm going to run it again. So now if we go to squirrel census 2, the geometry column is back, which means that it's now a shapefile again. So I'm going to take the name of this variable, squirrel census 2, and then plug it into the st_write function. And then I'm going to give the name, I'm just going to name it to whatever I want. So filtered data frame, just filtered squirrel census .shp. And that extension will essentially tell R that I want this to be a shapefile. So I'm going to highlight that and run it. Okay, so if we go to the folder where our working directory is, so the Central Park Squirrel Census folder, you can see that I now have a brand new shapefile, and that's the filtered squirrel census. And it'll look exactly like this. It'll have all the same features. It'll have 326 entries. And if you were to plot it in QGIS, it should look something like this. It'll have a limited number of dots compared to the original, and it'll have a very consistent one-dimensional age and fur color. Okay, so that's that really high-level introduction to working with shapefiles in R. I'm going to post a lot more content on this topic, so don't worry if you still have questions. Just let me know what they are, and I'll try to include them in the next video. And thanks for watching, and good luck.